Hello, I'm Robert, fact checker and science blogger, and this is about people who are scared of artificial intelligence and about why I think that Marvin in the Hitchhiker's Guide to the Galaxy is a far better representation of what something like that is likely to be if it ever is possible than something like Terminator, which doesn't really fit in, doesn't make sense on this with this kind of thing if it is possible. Personally, I don't think it's possible to develop artificial intelligence through machines. I think that we can, however, have what could be a superior intelligence to us according to some metrics by genetic modification. And I think it will come to the same endpoint because it's got to be something that is, it can't be something that is follows routines and is programmed. That is just not going to work. So it would be like genetically modifying, for instance, an elephant or a parrot. For example, a parrot has a very dense brain, tiny grey parrots, tiny brain. Then its brain cells, it's got enough of them to have similar intelligence to, say, an orangutan with a much more huger brain. If you could take the cells of a parrot and then somehow put them into a blue whale, say, and fill the entire brain of a blue whale with cells of a parrot, then you would probably have something that is super intelligent. And super intelligent in the sense of that it can probably make very long, complicated chains of inference very quickly and do lots of parallel thinking at the same time, can see hugely complex patterns that to us, like just we can easily see, if you've got 4 dots, we see a square. If you've got 1,000 dots, they'll probably see a million different patterns in them, just as instantly, and maybe 5-dimensional, 11-dimensional, 22-dimensional patterns in that scatter of dots, just immediately as we see a square. So that sort of intelligence would be possible. That's not necessarily more adaptive. If you look at super intelligent, the people who are very fast at thinking often come very quickly. I don't think the IQ test really tests. It's not an objective thing. If you look at the IQ test, then there are different components to it, such as your visual intelligence or your speech intelligence, your logical inferences. And someone who comes very quickly to a very complex decision as a result of very quickly going through a very complex argument in their mind in just a second, is not necessarily going to make a better decision than that someone who has a much shorter deductive process but is more grounded and more has a better understanding of how the world works. And you have things like emotional intuition as well. So someone might have actually pretty good ideas that would work and would be very effective, but if they don't have that emotional intelligence, then it's very hard for them to communicate these ideas to anyone else, so they'd be very ineffective. So I would expect a very super intelligent blue whale, say, might well just bewilder itself with these vast complexities of thoughts that it gets through in seconds, but at the end of it, it's looking both ways and looking at 1,000 different possibilities for even which way it could turn its head or something, and it could just end up just being totally baffled and confused, and it would probably get very depressed and very upset, and then it would see everything that it has to do as being so simple and so slowly and so little it can actually do. It can only wave a fin or maybe make a little hoot in its, make a little one of the whale calls, and maybe it can do speech and it can produce a few words, and it's got all these complex thoughts and it can't communicate with anyone. Unless we have a great deal of experience, I think it would be extremely cruel for future intelligence, for future civilization, once it knew how to do it, to make a blue whale with the brain cells of a parrot. Something as intelligent as that. And I think Marvin, the paranoid android, is an example of how it could go, but it could be much worse than that. Someone who's just constantly pessimistic, constantly, I'm sure many of you have heard it. Let's just play it.
I think you ought to know I'm feeling very depressed.
Well, we have something that should take your mind off things.
It won't work. I have an exceptionally large mind.
Yeah, we know, but we need you to go down to the number 2 entry bay and pick up our stowaways and bring them up here.
Just that? I won't enjoy it.
Yeah, well, that's life.
Life? Don't talk to me about life. I think that door just sighed. Ghastly, isn't it? All the doors in this spaceship have been programmed to have a cheerful and sunny disposition. Anyway, come on.
I think that's actually a pretty good depiction of what a future AI would be like if it ever was possible. So, as I said, I think it's probably only possible through genetic modification myself, but it's not necessarily, or something like that, but not necessarily through biology. There could well be some machine, something we think of looking much more like a machine, something that involves not organics, but some other substrate. So that's certainly quite possible. And who knows, maybe we have some insights from our understanding of computer programs that would help us to work with that. Our brains don't work even remotely like a computer program. So we have nothing, we don't have anything, we don't have any location where memories are stored. We have nothing resembling a hard disk, nothing resembling RAM. It doesn't seem to be stored in any particular place. There's nothing resembling a clock. There's nothing in our brain that does calculations. That is the central point of a computer program, that you have these chips that do these very rapid calculations and they do this logical processing. We have no logical processing units in our brains. We have no calculating units. We have no calculating chips. There's nothing there can add. There's nothing there can multiply that we know of, and we haven't found anything even remotely resembling anything that could add and multiply in our brains. And so the idea, there was the Blue Brain project, which tried to emulate our brains in silicon, and it got nowhere. So but it did very much a failed project. It did maybe got some insight, but it's hugely expensive, and it didn't really tell us much about how the brains work. And the one thing that we do have a slight analogy of in our brain are these neural nets. But neural nets don't have a memory. If you go and ask the Google Images neural net to remember images it saw in the past, it can't bring up the images that it were trained with. It's got a vague connection with what we do, but if we do use something like neural nets, which seems we probably do, it's certainly not like that, because it doesn't have a memory. And it's the other way around. A neural net also can't calculate. If you ask Google Images searching what's 2 plus 2, then the image search, then it would look for an image that has 2 plus 2 in it, and it has no way of actually doing calculations itself. And so we can combine that and get something that vaguely resembles what we do by adding in these units that do the additions and multiplication, but we don't have anything resembling those in our brain, and then by adding in the things like the memory locations, we can store things that you remember. We have nothing like that in our brain. So we are nowhere near understanding how our brains work, not even remotely, not even slightly, not even the slightest idea yet about how our brains work. Indeed, we don't understand how an amoeba works yet, because an amoeba has a kind of intelligence, can go and eat things and stuff like that. And an amoeba doesn't even have one neuron, and we don't know how an amoeba thinks and why it thinks. And it seems extremely unlikely to me that the way we think is through the interconnection of our neurons only. Each neuron is as complex as an amoeba, and so there must be stuff going on inside each neuron. It wouldn't make sense. Otherwise, an amoeba would outthink something with a brain with thousands, tens of thousands of neurons. That doesn't make sense. So I think our brains are vastly more complicated than we realise. Maybe many orders of magnitude. I think they're not even remotely close to computers that are of that complexity. And there's nothing in our brain that in any way resembles instructions. There are no computer instructions there. There's nothing. There's no sequence of bits. There's nothing resembling a bit or a byte. There's no noughts and ones in our brain. We have these spikes, or firing of spikes from the neurons, but they're very messy, lots of noise, and they don't really seem to be how we think. That doesn't seem to be what's going on there either. So whatever it is that we do, I personally think, from looking at what Professor Penrose's research, and my own personal research was in a similar topic area. I looked at the foundations of mathematics and logic, and things like Gödel's theorem were the meat of what I was looking at. And so I follow Professor Penrose's books, and he gave talks in Oxford. I was there before he wrote his books, and he was giving talks as he was preparing his books to the logic group there, which I was a member of, and both the philosophy of logic and the logic group I was there doing postgraduate. And so I've been following it since then, and I find his arguments very convincing, and based on those, and he was back and forth talking to logicians about it, so I was there listening to all these discussions, and based on his ideas, then I think that what we do is non-computational. And that's not new to Penrose. Gödel himself had that view. Gödel of Gödel's theorem, he's got a paper about that, where he says that what we think, that human thinking is can't be encoded into a computer program in any way, non-computable. Gödel came up with a very simple argument that he found convincing, but others, look at it and say, he doesn't close all the dot all the dots and cross all the T's, dot the I's and cross the T's. And I think it's probably fair to say that Professor Penrose doesn't dot all the dots and cross all the T's either. There's a kind of, it's very convincing if you are already that way inclined. But what the other people have certainly not done is proven that what we have in the brain is computable. And we have simple things that the radioactive decay is not computable. So that's a very simple example of something that is non-computable. You can't make a computer program that will generate a random sequence. You can only generate a pseudo-random sequence in a computer program. Indeed, you can define a random sequence as a sequence that can't be generated by a computer program. That's one way of defining it. And that's just a very simple example of something we can't do in a computer program. But so you can add a kind of physical randomizer. You can get a sensor that senses the movement of particles in the atmosphere, or you can have a radioactive decay thing. You can add that to a computer and add randomization. We are not just a computer program plus a randomizer. We're something far more complex than that. You can come up with much more complex descriptions of things that are non-computable, that you can prove can't be modelled in a computer program. Whether we can find actual physical processes that correspond to those things, that's the other question. And Roger Penrose, he went on to describe a way that he thinks that it's actually impossible to, actually is possible, wrong way round, it's actually possible that we are doing something non-computable physics involving, and he thinks, so quantum mechanics is not non-computable. The computations you can do with I'm not talking about quantum mechanics itself. The computations you can do with a quantum computer are still computable. A quantum computer can only do the same things you can do with a normal computer much faster. So far, there hasn't been any way to solve things that would otherwise be non-computable using a quantum computer. So that's why Roger Penrose went on beyond that to say, okay, what we're doing is non-computable. Maybe what we're doing involves the interaction of gravity with the other forces, which would seem rather extraordinary thing, but it's actually quantum mechanics, we've got a big gap between actually what the things leading up to an event, and then an actual event, the thing we actually observe. And that is called the collapse of the wave function. And this is the thing in quantum mechanics that has got no explanation as to how it happens. And then you have lots of philosophical hypotheses about what it means. And so he suggested that have a physical explanation of it, which involves involving the extra force of gravity, which he's an expert on twisters. It's his own theory, but looking at quantum gravity, basically incorporating gravity into quantum mechanics. And if you do that, then he thinks that we will find that the collapse of the wave function involves, in some way, gravity being involved with the rest of quantum mechanics, which has not yet been incorporated. That's his own personal view, but there could be lots of other ways. And physics can just be non-computable just with even basic classic physics. If you've got just two wheels and turning around, and if the ratio of the two of them together is something called Chaitin's constant, that was the ratio to the two rotation speeds, then that is something you could never simulate in a computer program. Just two wheels in an ideal physics, with one wheel going at a particular speed, another wheel going just an exact irrational and not transcendental speed faster than it. And just like pi, but this is a figure, this is called Chaitin's constant. That particular ratio of two speeds could never be simulated in any computer program. So you could just get an approximation to so many decimal places, not forever. So that's a simple example of something is non-computable. And what we do could, even in a completely classical physics world, could, if we just happen to have somehow through evolution, we got two wheels in our, I mean, it's obviously a ridiculous idea, but you could have these beings that just through chance had two wheels in their brains that were spinning at this particular ratio, and as a result, they could solve almost anything with just by using that constant, which you can use in a particular way in a particular programming language to tell whether any computer program is going to halt or not, and based on that, then you could solve all sorts of things that for us are unsolvable. So it's a very ridiculously simple world, but you can make this in an ideal sort of science fiction world where there's creatures that just happen to have two wheels in their heads that are spinning at different speeds, and then they have just the rest of it could be very much like our modern computers, just measuring the ratio of those two speeds to something to measures it, and as a result they can solve any problem in mathematics even if we couldn't, and to solve non-computable things. And so that's such as looking at a program that's never going to stop, and you can't prove it's going to stop within that particular language, but this can say it's never going to stop. You would solve anything like that just by having these two wheels. So the idea of that we could be doing something non-computable is not as strange as it seems. It's mainly a question of looking at how does it work in terms of physics. And so the idea is that if it is possible that what we do is that you could have creatures that evolve that have something non-computable, then evolution would find a way to do it. So because it'd be such an advantage to be able to do some non-computable things, leap to things that you can't do with a computer program, and because computer programs basically, Roger Penrose showed, are pretty dumb. Anyway, it seems he came to the conclusion that a computer program can never be programmed in such a way that it truly understands truth. It can't understand what's true and what's false. It can't make that distinction that to us is so clear. It can approximate it, but always you'll be able to find a way of pushing and finding a gap between its understanding and the world in such a way that you see something, it says something that we can see quite clearly is true, but the computer program is unable to resolve it. So it's not so much about it being a mismatch between itself and the world, but just not being able to see truth in the way that we can. That's what Roger Penrose came to that conclusion, and I think that's true also. It's certainly true of all the programs we've got to date. They make very dumb mistakes that to us are obvious that they're wrong. And so this is where his gets a little bit a little bit not quite hand wavy, but you know if you see what you partly see what you expect there, that the kinds of truths that are very complex, if we develop very complex adaptive things like Marvin, then there was actually a computer program, and if it got more and more approximating things quite well, the things that it would miss out on get more and more complex. But there's still things that if we could have that same complexity of mind as and be able to survey these things, we would still look at it and say, what a dumb mistake. You know, how could you possibly think like that? So it just gets more and more complex, and if you've got a computer program that could do vastly complex things, it would still make vastly dumb decisions that to us we just look at it and say, how could you possibly think that if we were capable of that level of complexity? And that's basically a summary of Roger Penrose's argument. And so that's where people start saying, but that's so complex we can never think like that. And so they say this is an invalid argument. But I think the basic idea behind it, that if something is vastly complex and you still make vastly complex dumb decisions, that's basically his conclusion. That no matter how complex you are, if it's programmed, if every detail is programmed, if there's nothing non-computable coming in, then all you're going to do is make more and more vastly complex. At some point there'll be a point where you could say something really dumb where it's clear there's no understanding of truth involved. And that's basically Roger Penrose's argument. And I find that convincing. And so, and anyway, so then the whole idea of like the robots, if we do produce robots, that if I'm, you know, if this is all wrong and then somehow we do manage to get something like this, and it does really understand truth, and there's some mistake in all that, even then, it's just going back to like the genetic thing. I think that if we do get to something like Marvin, there will be something non-computable in there. It's not actually following instructions. It's doing something a bit different. But whatever the reason, if once we get there, then whatever we construct is going to be something we've made. If it's a computer program, so we can decide how it goes. Or if it's completely programmable, and if it's done like that, then why would it have any motivation other than like the way we've designed it? But on the other hand, if it's something like a super intelligent whale, then it's just like a super intelligent human being, and we don't control all human beings, but they are part of our civilization. So this creature then, in the future, whether it's metal or whether it's made of organics, it would be another being in our civilization. It would like be incredibly brainy in some ways. It might be super good at solving certain kinds of mathematical problems. It might well be autistic. It might well have lots of issues with trying to communicate with other people, because it would just depend how it's evolved, or it could be the other way. But it's not likely that it would have some kind of fiendish desire to do something horrible to human beings. That seems incredibly unlikely. And it would either be very upset and just sad, and you know, if we're not very good at bringing up super intelligent beings, then I think it'd be quite cruel, and it might well be suicidal, and they might tend to kill themselves. And if the other possibility is that we do learn how to bring up a super intelligent creature like that, we give it the right nurturing environment, that might well be a future where you start thinking, oh well, this is a really quite a civilized ET we've got here, because they've got these super intelligent creatures and they're actually looking after them properly, and they're not just depressed like Marvin. They're actually living fulfilling lives, and they're super intelligent, yet they're still able to play a role in society. And then they come up with these hugely complex but sometimes dumb. So they're not going to be totally dumb like the Roger Penrose idea, where you just look and think, how do you think that at all? It's going to seem sensible to them. It's going to be based on understanding truth like we understand truth if it's a proper super intelligent creature. But it's not necessarily going to be a better understanding. We see that in our society, that people who are kind of very advanced in their understanding of one particular area are often pretty dumb when it comes to everything else. and it's just like the people who end up leading and being effective leaders and being effective at whatever they're doing, then they've got a certain something which you can't measure with intelligence, and it's just got such certain thing comes together, and if being very fast at thinking and being able to get together complex thoughts or trains of thought in your mind, and being very good at maybe visual processing and imagining, if you're being good at imagining, say, four-dimensional shapes or something, if these sort of things were things that were of great adaptive value to human beings, we would all be like that. Evolution would have selected those traits, and it hasn't. And evolution would be perfectly capable of making us super intelligent in according to these ways. I don't think there's any limit to the capacity of I think there's very little by way of limit to the capacity of human being, maybe none. We could have evolved, if it was of value to be super intelligent in this sense, then we would have evolved smaller and smaller brain cells like parrots did, and we would have become super intelligent creatures because it was such value. We would have found ways to make our brains even more able to do the processing they do. But that hasn't happened. So I think it's pretty clear that being super intelligent is probably quite maladaptive, and that having just the right span of the logical complexities, like they say that most of us, and I'm certainly an example there, can't keep more than three things in our mind at once. When I'm trying to think about, when I try to think about, remember things, very ordinary things, then I find it very hard to remember more than about three things. Like if I have an idea for a blog post and I haven't got anywhere to write it down, I think 1, 2, that was a good idea, that was a good idea. And another one comes up and I've forgotten the first one. And so that's quite common with human beings. I think maybe I can imagine 4 or 5 things after that I've forgotten, unless I've got something I can write it down on. And then you hope that when you come back to the situation, the ideas come up, and then from the context of before, these ideas come up again. But so we have very poor memories, really, but that doesn't seem to be short-term memories. Our short-term memories are almost dysfunctional for most people. And how many people can even remember a telephone number the first time you hear it? How many people can remember a chain of, say, 20 numbers? You just say 20 numbers and then they just say it back to you. So that is certainly something that we could easily have evolved if it was useful. If it was useful to be able to remember 20 numbers, then everyone would have evolved that by now. It can't be that difficult to evolve a brain that can remember 20 numbers. But we don't have that. So that would be an example, a simple example of a kind of super intelligence. Is just having a very good short-term memory, or long-term memory indeed, that some could give you a sequence of 20 numbers. So some people have these. Another example is memory of faces. So I'm actually very poor at face recognition. I'm gradually managing to improve it. But you have these super recognizers who can remember the face of everyone they've seen. They just go on a bus, and by the end of the bus journey they know the faces of all the people. They walk through a crowd, they can remember the face of all the people they've walked past them, called super recognizers. And because some people can do that, that is clearly an ability that anyone could have if evolution was to select in favour of that. So there has to be some reason why that is not an adaptation that is. So it seems that these things, there's enough value for a few people in our species to have each of these capabilities. So capability of a super recognizer, capability of being very intuitive. I think autism also is a capability that it's useful to have a certain percentage, and quite a high percentage, in our society. I think that's a capability that the civilization our species needs. Otherwise, it wouldn't have survived evolution. and so we have this situation where a certain percentage with a certain extension of capabilities, and so some people do have a very good memory, and some people are very fast at calculating things, and so on. But it seems to be in a situation where our species is very diverse, and there's a little bit of each of these things in different people, and some people are very much one of those, another person is very much another one. And although evolutionary, there's no reason why we shouldn't all be super recognizers, we shouldn't all have the capability of remembering 1,000 things at once, we shouldn't all have the capability of seeing an entire logical argument of 1,000 steps at once or something. I don't think that's beyond the capability of our brains. I think it is rather that it's not evolutionarily selected for, and that people are able to do all those things. Actually, it's maladaptive if you have too many people in society do that. And you can understand why. I mean, if you've got a saber-toothed tiger roaming around your cave, and you spend about an hour deciding what you should do because you think about all the different possibilities, then that's not very adaptive, is it? And if you're kind of remembering 1,000 different things, then maybe that distracts you away from what you need to do. And the people who are able to make very complex reasoning are not necessarily, and they often are not, very good at navigating the situations that they find themselves in life. They're just too much in a whiz of thinking about all these things, and they get bewildered, and they build up complex structures that don't actually. You often get people who build up complex, trying to interpret other people, for instance, understanding them, and they build up this huge complex personality for someone else, which doesn't match them. It doesn't match how they actually are. So you get people who are also very intuitive and empathic, but they go overboard, and they imagine all lots of complex stuff about someone else, and then it's just not correct. That happens a lot also, and that our super intelligence might well do that as well. So I think that if our future civilization does have these super intelligent creatures, whether they're robots or whether they're genetically modified, whether they're made in factories or whether they're genetically modified, I think that they are going to be just another facet of our complex evolving civilization, and then they will have to develop their role, and then we will have to support them. And just like you have to be, like for instance with autistic people again, then other people have to be understanding of how they behave, and understand and help them become part of the society. In the same way, I expect the likes of Marvin in the future to be quite, many of them may be quite maladaptive and very difficult to actually integrate into our society. And we might well need to learn quite a lot about how to interpret and the best ways to communicate with them, the best ways to help them to lead meaningful and fulfilling lives. And so that is how I see this. I think that we are nowhere near. And I just want to say, if you've ever seen Sophia, for instance, there are all these things. It's just smoke and mirrors. Sophia can't understand anything. Sophia is just a chatbot that has had very long paragraphs programmed into her. She just says, if you've got this, do that. She's like Alexia, where you can program a response to whatever you say. And she's just basically a very complex form of Alexa. And and then these long things that she says with a kind of mannequin that is programmed, not programmed, that is that with lip sync of the lips, and with movement of the eyes and expressions programmed in, that it can generate certain expressions in particular points in the script, and that it can good vocal synth, and it's basically like the whole precedence. That's what it's just something saying speeches, but they're more flexible. The speeches, there's nothing there that knows what a robot is. There's nothing there that knows what a human is. There's nothing there that understands even a word of that speech. And if you were to deal with that by setting up careful interview situations where they don't have fast back and forth dialogue. They often pre-vet the questions before they give them to her. They know in advance of what these people are going to ask her, and then they select the best examples to put up as videos. There's nothing there that understands anything. It's not even remotely. It's just a chatbot. And if you try chatting to chatbots, they may seem very intelligent to start with, but then you ask them something like, do humans breathe oxygen? And say something, they probably can if they want to or something. And is oxygen poisonous? And they don't know what you're talking about. So that's the sense in which I think in the foreseeable we have nothing at the moment that has an ordinary basic understanding of truth, of simple things. And then can make it more, if you can deal with more and more examples of situations, you can make it seem to have some understanding, but it's just looking up things basically. And if you look up, and then if you go beyond what it's actually been put in for it to look up and to kind of try and make connections between, and then it'll say something totally dumb, because nothing there it actually understands. And so far, we have not yet come up with anything programmed that will not occasionally say something totally dumb in response to ordinary situations. And there's nothing there. We are nowhere near anything like the level of Marvin. Nothing, not even remotely. So this is not something to worry about in the near future. There are plenty of reasons to have some concern about artificial intelligence. For instance, the stock markets crash possibly due to artificial intelligence. So you've got to look at how but it's a tool. It's a tool like any other ones. And the possibility of various ways you can use artificial intelligence. Some are good, some are bad, but it's not. The word is a misnomer. It's not really intelligence as we understand intelligence. Sort of artificial complexity, kind of dealing, being able to write programs that can come up with reasonably good solutions in very complex situations that, for the most part, within the parameter space of what you want to achieve. Something like that would be a reasonable description of what our artificial intelligence is like today. And I just see that as, in the future, developing to more and more complex situations and more intricate parameter space of what we want it to be able to do. But I don't see it making that jump so as to actually anything that's programming anything that actually has understanding. And it's always got to be grounded by a human being looking at the situation, looking at what it's doing and saying, that's not sensible, let's tweak it a bit. I think that's basically what artificial intelligence is going to be like into the future, always directed by humans, working out what's sensible and what's not, and tweaking it if it gets it wrong. I think for the foreseeable future, that's what our artificial intelligence is like, and people need to be very aware of the limitations. Anyway, I hopefully this is kind of interesting and help you see some of the background to this. To someone, I've got background in logical foundations of maths and Gödel's theorem, and also do a lot of programming myself, not in the particular field of artificial intelligence, but I think this may give an interesting perspective on this whole. Apart from, it's one of my debunks is actually speaking to my own core mathematical expertise. So, what I did, I never got my thesis, but my supervisor said that I shouldn't try again. I was saying something very quite. He said that I should instead try and get my papers published, and then submit, ask for a doctorate, a DSc, a doctorate by research. And so I've still got those. I've got a draft paper actually, but I never tried to publish it. I got so disheartened that I stopped at that point. But I could still do that. But that's why I ended up doing all sorts of other things. Instead, I ended up doing my programming and things, and I followed a different direction at that point. But yes, so I've never got my doctorate, but this was the area was an area very close to my area of research.